My name is Harish Gopale. Welcome to my YouTube channel, Export. On this channel, I dive deep into the world of technologies such as fundamentals of system Verilog, fundamentals of UVM, and basic fundamentals of digital electronics. So, in today's session, we are going to explore systematic approach to construct the complex muxes by using simple one such as 4 is to 1 mux by using 2 is to 1 multiplexer and 8 is to 1 multiplexer using 2 is to 1 multiplexer. Similarly, 8 is to 1 mux by using 4 is to 1 mux and 2 is to 1 mux. And similarly, 16 is to 1 mux by using 4 is to 1 multiplexer. Additionally, we are going to implement non-standard mux such as 10 is to 1 mux by using 4 is to 1 multiplexer. Okay. So let's get start with the implementation of 4 is to 1 mux by using 2 is to 1 mux. Here on my screen you can see this is the gate level schematic of 4 is to 1 mux. It is having 4 inputs I0, I1, I2, I3 to select lines A and B and one output that is Y. So output Y is determined based on the select line. If select line AB is equal to 0, 0, input I0 will be routed to the output. Similar with all the inputs. And above that you can see the truth table. A and B are my select line and Y is the output. So based on the combination of select lines, inputs will be routed to the output. So uh, you can see on my screen to implement this 4 is to 1 mux by using 2 is to 1 mux, we need 3 2 is to 1 mux. Okay. So here also our inputs are I0, I1, I2 and I3 and our output is Y and select line is A and B. Okay. So to understand this, we will split this combination of 3 2 is to 1 mux into two stages. This first 2 is to 1 mux and second 2 is to 1 mux is my first stage and this is my second stage. So let's understand. So if my select line B is equal to 0, so from this first 2 is to 1 mux, I0 will be routed to the Y0 and from the second 2 is to 1 mux, I2 will be routed to the Y1. Now select line A will decide from this input Y0 and Y1 which input will be routed to Y. If select line A is equal to 0, then Y0 will be routed to the Y. That means I0 will be routed to the Y. If select line A is equal to 1, then I2 will be routed to the Y. Similarly, if select line B is equal to 1, so from this 2 is to 1 mux, I1 will route it to the Y0 and from these 2 is to 1 mux, I3 will be routed to the Y1. Now, if select line A is equal to 0, then I1 will be routed to the Y and if select line A is equal to 1, then I3 will be routed to the Y via Y1. So this is how we can implement 4 is to 1 mux by using 2 is to 1 mux. Okay. Now let's jump to the implementation of 8 is to 1 mux by using 2 is to 1 mux. Here also you can see the gate level schematic of 8 is to 1 mux. It is also having 8 inputs that is I0 to I7 and to implement this 8 is to 1 mux we need 3 select line. So A, B and C is my select line and Y is my output. So based on the select line, one of the inputs from the 7 input will be routed to Y. Okay. Beside that, you can see the truth table. Here A, B, and C. If A, B, and C both are low, then input I0 will be routed to the Y. Okay. So you can see on my screen to implement this 8 is to 1 mux by using 2 is to 1 mux, we need 7 2 is to 1 muxes. Okay. Here also our inputs are I0, I1, I2, I3, I4, I5, I6 and I7 and the select lines are A, B and C. So that is A, B and C. So to understand the working we can split this into three stages. This first 4 is to first 4 2 is to 1 muxes are my first stage. This is my second stage and this is my third stage. Okay, so let's understand if my select line is C is equal to 0. So from this first 2 is to 1 mux, I0 will be routed to Y2. From this 2 is to 1 mux, I2 will be routed to Y3. From this 2 is to 1 mux, I4 will be routed to the Y4, and from this 2 into 1 2 is to 1 mux, I6 will be routed to Y5. Now based on select line B, if my select line B is equal to 0, then I0 will be routed, then the I0 which is already routed into Y2 will be routed to Y0. Yeah, if select line B is equal to 1, then I2 will be routed to the Y3, that is, and Y3 will be routed to the Y0. In this sixth 2 is to 1 marks, if select line B is equal to 0, then for the I4 which was routed into Y4, that will be routed to the Y1. If select line B is equal to 1, then I6 will be routed to the Y1. Now select line A will decide whether Y0 will be routed to the Y, or Y1 will be routed to the Y. If select line A is equal to 0, then whatever I0 is routed to the Y0, that will be routed into the Y. Means if A is equal to 0, B is equal to 0 and C is equal to 0, then I0 will be routed to dy. If A is equal to 0, B is equal to 0 and C is equal to 1, then I1 will be routed to dy. If A is equal to 0, B is equal to 1 and C is equal to 0, then I2 will be routed to the Y. Here you can see A is equal to 0, B is equal to 1, C is equal to 0, I2 is routing to the output Y. If A is equal to 0, B is equal to 1 and C is equal to 1, then I3 will be routed to the Y. Similarly, if A is equal to 1 and B is equal to 0 and C is equal to again 0, then I4 will be routed to the output Y. So this is how we can implement 8 is to 1 mux by using 2 is to 1 muxes. Till now you can understand we needed if we go to implement 4 is to 1 mux by using 2 is to 1 mux, in that time we need 3 is to 1 muxes. Here also we saw to implement 8 is to 1 muxes by using 2 is to 1 muxes, we needed 7 2 is to 1 muxes. So if someone asks you to implement 100 is to 1 muxes, how much 2 is to 1 muxes will be needed? The answer will be very simple, 99 muxes. Okay. Now we'll implement 8 is to 1 mux by using 4 is to 1 mux and 2 is to 1 mux. Here on my screen you can see the gate level schematic that is already I have explained you about while implementing 8 is to 1 mux by using 2 is to 1 mux. And this is the truth table which is having select line A, B and C and output Y. So based on the select line A, B and C, inputs from I0 to I7 will be routed to the output Y. Okay. So as you can see on my screen, to implement these 8 is to 1 mux by using 4 is to 1 mux and 2 is to 1 mux, we need two 4 is to 1 muxes and single 2 is to 1 mux. And we are having inputs I0 to I7, okay, and select lines A, B and C. So to understand this, we'll split this combination of 4 is to 1 mux and 2 is to 1 mux into two stages. So this 4 is to 1 mux, this is the first 4 is to 1 mux and this is the second 4 is to 1 mux is my first stage, and this single 2 is to 1 mux is my second stage. As you can see, for both these 4 is to 1 mux, B and C are the common select line. So if B and C both are 0, both are 0, then from this first 4 is to 1 mux, I0 will be routed to the Y0, and from the second 4 is to 1 mux, I4 will be routed to the Y1. Now based on the select line A, Y0 are y1, either y0 or y1 will be routed to the y. So if select line A is equal to 0, then y0 will be routed to the y. Or if select line A is equal to 1, then y1 will be routed to the y. That means if select line A is equal to 0 and select line B is equal to 0 and C is equal to 0, then I0 will be routed to y0. If select line A is equal to 0 and B is equal to 0 and C is equal to 1, then I1 will be routed to the y. If select line A is equal to 0, B is equal to 1 and C is equal to 0, then I2 will be routed to the y. If select line A is equal to 1 and B is equal to 0 and C is equal to 0, then I4 will be routed to the y. Similarly, from I0 to I7, all the inputs will be routed to the Y based on the select line only. So this is how we can implement 8 is to 1 mux by using 4 is to 1 mux and 2 is to 1 muxes. Okay. Now we'll implement 16 is to 1 mux by using 4 is to 1 mux. Here on my screen you can see the gate level schematic of 16 is to 1 mux, which is having 16 inputs from I0 to I15. I0, I1, I2, I3, I4, I5, I6 with I15 till I15. So and select lines are four select lines A, B, C and D are my four select lines, and this is the Y is the output. So based on the select lines, any one inputs will be routed to the output. Okay. Beside that, you can see the truth table. These are my select lines A, B, C, and D. So if A, B, C, and D both are low, then input I0 will be routed to the output Y. If select line A is equal to 0, B is equal to 0, C is equal to 0, and D is equal to 1, then input I1 will be routed to output Y. Similarly, if A is equal to high, B high, C also high, and D also high, then input I15 will be routed to output Y. Okay, so to implement this 16 is to 1 mux by using 4 is to 1 mux, we need 5 4 is to 1 muxes. Okay, so here also you can see we are having 16 inputs from I0 to I15 and for select lines that is A, B, C and D. Okay, to understand this implementation, we will split this into two stages. This is my first stage which is having 4 is to 1 muxes, and this is my second stage which is having single 4 is to 1 mux. So, and as we already know, the functionality of 4 is to 1 mux, which is having which is having four inputs and two select lines. So based on select line, the inputs will be routed to the output. Okay. So now let's get understand. So you can see here C and D are the common select line for all four is to 1 muxes. So if C and D are 0 0, so from this first 4 is to 1 mux, I0 will be routed to the Y0. From the second 4 is to 1 mux, I4 will be routed to Y1. From this third 4 is to 1 mux, I8 will be routed to the Y2. From this fourth 1 is to 4 is to 1 mux, Y12 will be routed to the Y3. Now, based on the select line A and B, from these four inputs Y0, Y1, Y2, and Y3, this will be routed to the Y. So already input I0 has routed into Y0. So if select line A and B is equal to 0 0, then Y0 will be routed to the Y. That means indirectly I0 routed to the Y. So similarly, if select line A and B are 0 0 and select line C and D are 0 1, then I1 will be routed to the Y. If select line A and B are 0 1 and select line C and D are 0 0, like select line A and B are 0 1 and select line C and D are 0 0, then I4 will be routed to the output Y. Okay, so this is how we can implement 16 is to 1 mux by using 4 is to 1 mux. Okay. Now let's implement non-standard multiplexer such as 10 is to 1 multiplexer by using 4 is to 1 multiplexer. So for that, first we'll draw the truth table. Here on my screen you can see the truth table. Our inputs will be 10 inputs from I0 to I9, and select line will be 4. We need 4 select lines to implement this 10:1 multiplexer, and our output will be Y. So based on the combination of select line, our inputs will be routed to the output Y. Okay. So to implement this 10:1 multiplexer by using 4:1 multiplexer, we will draw a combination of 4:1 multiplexer. On my screen you can see I have draw 4 combination of 4:1 multiplexers. For these multiplexers, our inputs are the I0 to I9. Okay, I10 and I11 are the inputs, but that are grounded. See, if we have taken 4 select lines, so as per the combinations, it will create 16 combinations. But we have to implement only 10:1 multiplexer. So that is the reason remaining combinations are grounded. Okay. Now to understand this implementation, we'll split this combination of 4:1 muxes into 2 stages. This will be my first stage, which is having 3 pair of 4:1 muxes, and for each 4:1 mux, C and D are my common select line. In the second stage, we are having only single multiplexer, which having select line A and B. Okay. So now if select line C and D are 0, so from this first 4:1 mux, I0 will be routed to the Y0. From the second mux, I4 will be routed to the Y1. From this third mux, I8 will be routed to the Y2. Now, based on select line A and B, these Y0, Y1, Y2 and Y3 will be routed to Y2. Why? So, if my select line A and B is equal to 0, 0, so already I0 routed into the Y0, so Y0 will be routed to the Y. That means indirectly I0 will be routed to the Y. So if select line A and B is equal to 0, 0 and C and D is equal to 0, 1, so I1 will be routed to the Y. Similarly, if A and B is equal to 0, 1 and C and D will be 0, 0, so I4 will be routed to the Y. You can see A and B are 0, 0, 0, 1 and C and D are 0, 0, then output Y having I4. Similarly, if select line A and B are 1, 0 and C and D are 0, 1, then I3, that means 10th input will be routed to the output Y. Okay. You can see this I10 and I11, these are grounded. Okay. Even for select line A and B high, the inputs are routed to the ground. The inputs are grounded, inputs will be routed to the output Y. So this is how we can implement a 10:1 mux by using 4:1 mux. Here we'll stop the video. If you are watching this video, then please like the video and comment me how it is. Again, on what concepts you want the videos. And please subscribe my channel and share with your friends also. Thank you so much.